So today we're going to look at the second half of lesson 13-4. So I apologize, you're probably going to hear my granddaughter in the background. She's very loud, and I'm in a whole different room on the opposite side of the house. Anyway, today we are going to focus on using reference angles to find trig values, sine, cosine, tangent, and any of the reciprocal functions. So, a couple things that are important. Thing one, you are going to find the measure of the reference angle. In order to do that, you're going to need to put that angle. So let's say that this is, oops, that's not what I wanted. Let's say that this is the coordinate grid. Okay, you're going to have to decide where's the terminal side of the angle that you're looking at. Is it in quadrant 1, 2, 3, or 4? And let's just say for chuckle's sake that your terminal side ends up over here in quadrant 2. That means that your angle is going from here to here. You are going to create a right triangle by dropping down the vertical towards the x-axis. So if you're in quadrant 2, it's going to look like this, and this is where theta prime will be. That's your reference angle. You'll figure out how much further from here you have to go to get to the x-axis. If you're in quadrant 1, your terminal side might be there, and so of course you would create the right angle here, and theta prime would be there. And then if you're in quadrant 3, your terminal side might be here, so then you would go up to the x-axis, and theta prime would be here, so it's starting to look like a little bow tie. In quadrant 4, you might be there. You'd have to go up to the x-axis, but your theta prime would be there. So you're going to create one of these 4 triangles, and you're going to use only the reference angle, the distance that your angle is from the x-axis. So either 180 degrees or 0, or if you're coming through on the 4th quadrant, it could be 360 degrees. Today we're only going to work with positive angle measures, but the same thing will work if we did negative angle measures. So I'm going to expand this really, really big. Oh, before I do that, let's go through the rest of our items that we might have to do here. So then you are going to identify the trig function that belongs to that reference angle, theta prime. So is that going to be sine? Is it going to be cosine? Is it going to be tangent? You're going to be told which one you're finding, and then look for that ratio that goes along with some old hippie caught another hippie tripping on acid. If you're given a reciprocal function like secant or cosecant or cotangent, you're going to find the sine, cosine, or tangent that goes with that, and then just take the reciprocal of it. That's why it's called a reciprocal function. And then finally, of course, you are going to adjust the sign if needed. So here we go. I'm going to make this really big. And even if you are memorizing the unit circle, I still want you to show where that angle is. I'm trying to make this straight. This is a little crooked in this PDF. You still have to show me where that angle sits in the coordinate grid. So sine of 50 degrees, here's my coordinate grid, so 150 degrees should be in quadrant 2. So your terminal side is going to be here. So your angle goes from here to here. But you're going to create your right triangle here. This is where theta prime is, and I know that your paper is really tiny, so if you would prefer to do your work on a separate sheet of paper and then just use the questions in there as a reference, just write down the original problem so you have it with you. All right, so that's my theta prime. If this is 150 degrees, how much more do I need to get down here to 180? Well, that's a difference of 30. So theta prime is equal to 30 degrees. So I'm going to replace, well, I guess I'm not going to replace that. It won't let me. So I'm going to put that 30 degrees right in here. Okay? So then if that 30 degrees is my angle of reference, then that means that 60 degrees must be up here. So I have a 30, 60, 90 triangle. And of course, across, I'm going to get some good colors. Nope, don't like that. Maybe, aha, there's a good color. All right, so this would be my side opposite. So, well, I'm just going to do 1. Across from 30 would be 1. Across from 60 would be radical 3. And the hypotenuse, of course, is 2. Remember that we have to pay attention to signs. So in quadrant 2, the x-axis is negative, the y is still positive. So I should have a negative in front of that rad 3. And this is my angle of reference right there. So my side opposite is over here. My side adjacent is down here. And my hypotenuse is here. My handwriting on this is just atrocious, so I just apologize. All right, so for sine, of course, is equal to some old hippie. So my opposite is 1, and my hypotenuse is 2. So the work I'm looking for is the following. Number 1, I want you to at least put your triangle in the quadrant that it belongs to for your angle. I need to see what is your reference angle, so what's theta prime, and then you can find sine, cosine, tangent, whatever it is that you're looking for. So if you've got it memorized that the sine of 30 degrees is 1/2, which it is, then you're good as long as you pay attention to which trig functions are positive in which quadrants, which we went over yesterday. So all students take calculus. So all are positive in this quadrant. Only sine is positive, and it's reciprocal. Everything else is negative. In quadrant 3, only tangent and its reciprocal are negative, or are positive in this quadrant. The rest are negative. And in quadrant 4, for calculus, cosine is the only one that's positive with its reciprocal function. Everything else is negative. So because we're in quadrant 2, which is sine, it does make sense that sine is positive because that's students, right? All right, so we're done with that one. So we're going to move on to 6. So I want you to draw where 300 degrees is and then restart the video. All right, so here's your quadrant. 300 degrees should be in quadrant 4. So you're going from here to here. That's your 300 degrees. So the difference between, and on this side of the x-axis, this is 360. So the difference between 300 and 360 is, of course, 60 degrees. So there's my theta prime. So theta prime, my reference angle, is 60 degrees. You remember your reference angles are always positive. And so then I'm going to take that triangle all the way up to the x-axis. And if that's 60, this is 30 here. And then I'm going to write out my side length. So across from 30 is 1. Across from 60 is radical 3. And the hypotenuse is 2. Pay attention to your signs. In quadrant 4, x is positive, but y is negative. So I need to attach a negative onto this. And then I'm just going to start to abbreviate my opposite adjacent hypotenuse. So this, according to my angle of reference, which is 60, this is side opposite, this is side adjacent, and this is my hypotenuse. So tangent of 300 degrees is equal to, and I am tripping on acid. Now, if you have memorized the tangent of 60 degrees, well, by all means, you don't have to do tripping on acid, but I'm going to. And so opposite is negative radical 3, and adjacent is 1. So of course, negative radical 3 over 1 is negative radical 3. All right, so we're going to move on to 7. So again, I'd like you to try this one on your own. If you're not comfortable, you can I'm going to keep working every single problem of 5 through 16. So if you feel confident, you can work ahead and then just check your answers, that type of thing. So here's my coordinate grid. 225 is greater than 180, but less than 270, so it belongs in quadrant 3. And so I'm going to bring that triangle all the way up to the x-axis. And so our angle goes from here to here, right? But theta prime is right in here. This is theta prime. And so if we're looking at 225, the difference from 225 to 180 is 45 degrees. So theta prime that's my reference angle, is 45 degrees. Now I happen to have it memorized that the cosine of 45 degrees is rad 2 over 2, but I'm just going to prove it to you. So my 45 degrees is going to go inside here, so this is 45, 45. And of course the side lengths of our 45, 45 triangle are 1, 1, radical 2. Pay attention to your signs. X and Y are both negative in quadrant 3. So when we find the cosine of 45 degrees, which is the same as the cosine of 225, we have caught another hippie. And so our side adjacent is okay, so I didn't write those. So here's your angle of reference. I really feel like I need a different color. That one's not different enough from my other ones. So, I don't know, maybe I'll use fuchsia. Okay, so this is side opposite. This is side, oh, I'm not going to use a lowercase. This is side adjacent. And this is my hypotenuse. So, now, my side, I'm messing up with my controls over here, sorry. So my side adjacent is -1, and my hypotenuse is the square root of 2. And of course, we're going to rationalize this by multiplying rad 2 over rad 2, and we end up with negative radical 2 over 2. And of course, I said that the cosine of 45 degrees was radical 2 over 2, but you do have to pay attention to the sign in quadrant 3. Tangent is the only function that is positive in quadrant 3. All students take. So tangent is the only one that's positive, so everything else needs to be negative. All right, moving on to 8. So 8 is cotangent. Cotangent is an inverse function, or a reciprocal function. So cotangent is equal to 1 over the tangent of 315 degrees. So we're going to find tangent of 315. So 315 degrees is greater than 270, but less than 360. So my terminal side is going into quadrant 4. I'm going to create that right triangle up to the x-axis. My reference angle is going to go here. So if this is 360, the difference from 315 to 360, because my angle, of course, goes from here to here, right? So that's that 315 degrees, would be, again, 45 degrees. So theta prime is equal to 45 degrees. So we have a 45, that's terrible. We have a 45, 45, 90 triangle. So pay attention to your signs. This is my angle of reference. So across from it is -1, because your y's are negative in quadrant 4. And then across from the other 45 is a +1, and your hypotenuse is radical 2, just like we did before. All right, but tangent is going to be, let's see, this is side opposite, this is adjacent, and this is your hypotenuse. So tangent is going to be tripping on acid. So this is going to be 1 over, and then here's my ratio for tangent. If I am tripping on acid, I'm going to put opposite is -1 and acid is +1. So -1 over +1 is equal to -1, and of course that equals -1. All right, next is going to be number 9. So now we're dealing with tangent. I'm mostly concerned that I have 240 degrees. So 240 degrees is greater than 180 but less than 270. So that puts us in quadrant 3. And the difference between 240 and 180 is 60 degrees if you subtract those. So theta prime is 60 degrees. So I'm going to put 60 here, that's my theta prime, and then that means this angle over here must be 30. And of course across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. But if you pay attention to signs, both x and y's are negative in quadrant 3. And if this is my angle of reference, my side opposite is here, my side adjacent is here, and this is my hypotenuse. My granddaughter's favorite word is high, so that's what she's yelling in the background. She's hilarious. All right, so tangent. We are tripping on acid. Of course, if you have memorized the tangent of 60 degrees, feel free, but I'm going to do opposite, which is negative radical 3, over the adjacent, which is -1. So 2 negatives make a positive, and we don't write anything over 1. So the tangent of 240 degrees is the same as the tangent of 60 degrees, and so they're both radical 3. And tangent is positive in quadrant 3. I always like to check my sign because all students take. So take is the one that tangent is the one that's positive in quadrant 3. All right, so good job if you're getting these right. So then number 10 is secant. Don't let it bother you that it's secant. I'm most concerned right now about the 300 degrees. All right, so then 300 degrees is in quadrant 4. And then we're going to go up to the x-axis. And of course, this is where theta prime is, our reference angle. 300 goes from here to here. And the difference between 360, which was right here, and 300, so theta prime is going to be 60 degrees. So we have another 30, 60, 90. So my reference angle goes here. That means this one must be 30 degrees. And then opposite 30 is 1, opposite 60, radical 3, and your hypotenuse is 2. Pay attention to your signs. X is positive, but Y is negative. And if this is my angle of reference, opposite 60 is over here, adjacent is right here, and of course this is the hypotenuse. So for secant, secant is a reciprocal function. So it is the reciprocal to cosine. So secant is 1 over the cosine of 300 degrees. So we are going to do 1 over, and we have this ratio. So because it's cosine, we have caught another hippie, right? So another is 1, hypotenuse is 2, and so if you do keep, change, flip, or really all you have to do, because it's under 1, is you're just taking the reciprocal of 1/2. The reciprocal of 1/2, or you can keep change flip, is just 2. And because it's cosine and secant are going to have the same sign in quadrant 4. Quadrant 4 is all students take calculus, so because it's calculus, cosine is the one that's positive, and so that makes sense that it's a positive 2. Now Maddie K is not getting her way. She's very mad. Sorry. It's my only time I can make the video. I apologize. All right, so now we're getting into some radian measure. So apparently we were hungry, so I have gotten Madison something to eat, so perhaps we can have some more peace and quiet. Okay, so if this is in radians, unless you've memorized what the cosine of 11 pi over 6 radians is, which is on the unit circle, I would suggest that you convert it. So if we're going to convert radians to degrees, we are going to use 180 degrees over pi. And so of course you're going to let your calculator help you out with this. So 11 times 180, enter, and then divided by 6, enter, and you should get 330 degrees. That enables us to determine where in the coordinate grid 11 pi over 6 is, and also what degree it is, what the reference angle is. So that means that 330 degrees is in quadrant 4. So we're going to go up to the x-axis. And then, so that means from here to here, right, is your angle, but your reference angle goes here. So if this is 360 and this is 330, the difference between 360 and 330 is what your reference angle is. So theta prime is 30 degrees. So 30 degrees goes in here as your reference angle. That means this is 60 degrees down here. And then across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. You've got to pay attention to your signs. In quadrant 4, only y is negative. So then this is our reference angle. So according to that angle, this is side opposite, this is side adjacent, and this is the hypotenuse. Well, we want cosine, right? So cosine is equal to cot another hippie, right? So cot another hippie should be adjacent, which is radical 3, over 2, which is our hypotenuse. Remember, cosine is calculus. All students take calculus, so cosine is positive in quadrant 4, and so that makes sense that this is a positive radical 3 over 2, and that does not reduce, and so we're done. All right, then number 12, don't worry that it's cosecant. Your first job is to convert. So convert 7 pi over 4, multiply it by 180 degrees over pi. Let your calculator do the work. And so 7 times 180 and then divided by 4 is going to give you 315 degrees. So we're really looking at the cosecant of 350 degrees, which is equal to 1 over, cosecant is a reciprocal function to sine, so it's 1 over the sine of 315 degrees. Well, 315 degrees is in quadrant 4. So from here all the way to here is 315 degrees. So the difference from 315 to 360 is 45 degrees. So I'm going to bring this up to the x-axis. My reference angle theta prime is 45 degrees. So that is going to go here. That means my other angle is also 45 degrees. And then the sides opposite 45s are 1, 1, and then radical 2. And in quadrant 4, y is negative. And so we have 1 over the sine. So we've done this numerous times already, right? So sine is some old hippie. And your opposite is, here's your angle of reference right here. So this is your side opposite. And it's really important because your sine is going to be in effect here. This is your adjacent and this is your hypotenuse. So for our side opposite, we actually have -1 over the square root of 2. Instead of rationalizing that, since it's 1 over a fraction, we're just going to take the reciprocal of -1 over the square root of 2, which is equal to the square root of 2 over -1, which of course equals negative square root of 2. So the secant of 315 degrees, which is also, or I'm sorry, the cosecant of 315 degrees, which is also 7 pi over 4, is the same as negative square root of 2. All right, number 13. I highly suggest you try this on your own. Pause the video and then restart it. If you haven't been doing that yet, you should be at this point. So this is 180 degrees over pi. We're going to multiply that. The pi's cancel. And if you throw that in your calculator, 4 times 180 divided by 3 is 240 degrees. So it's the sine of 240 degrees. So 240 degrees is actually in quadrant 3 because it's between 180 and 270. And so we're going to bring this up to the x-axis. So from here to here is the 240, but right here is our reference angle. So our reference angle, theta prime, is equal to, so if I've got 240, 240's here and 180's here, the difference between 180 and 240 is 60 degrees. So we're really looking for the sine of 60 degrees. So if you have that memorized, perfect. If you don't, we're going to derive it from our special right triangles. So across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. In quadrant 3, both the x and the y, whoops, that's hard to tell, both the x and the y are negative. That's supposed to be a little negative there. Okay, so then this is my angle of reference, this is my side opposite, this is my adjacent, and my hypotenuse. So I've got some old hippie, right? So opposites of 60 is negative radical 3, and hippie, my hypotenuse is 2. That does not reduce. And so there you go. And of course, sine is negative in quadrant 3 because this is take, which means tangent. Tangent's the only one that would be positive. All right, on to number 14. We only have 3 more. Then we are going to multiply this by 180 degrees over pi to convert it. Pi's cancel. 3 times 180 degrees, and then divided by 4 is 135 degrees. So a 135 degree angle is in quadrant 2. So that angle from here to here, 135 degrees. We're going to bring that down to the x-axis to create our right triangle. So theta prime, which is of course right here, is the difference between 135 and 180. So the difference between 135 and 180 is 45 degrees. So I told you we'd be using this a lot, but we are doing tangent. Most of you won't have tangent memorized. So I'm going to put my reference angle in here of 45 degrees. That means this one is 45 degrees. And then the side opposite each of the 45s are 1 and 1, and the hypotenuse is radical 2. in quadrant 2, only x is negative, so that one is negative. This is my angle of reference, so this is my opposite, this is my adjacent, and this is my hypotenuse. So for tangents, we have, my husband just came home, and he is my granddaughter's favorite person in the world. So now she's going to be screaming his name. So now we are tripping on acid. All right, so our opposite, our on, is the 1, and our adjacent is the negative 1. So 1 over negative 1 is equal to negative 1. So the tangent of 3 pi over 4 turns out to be just negative 1. All right, 2 more. Number 15, you want to convert this by multiplying this by 180 degrees over pi. Pi's cancel. 7 times the 180 degrees, then divided by 6, turns out to be 210 degrees. So we're finding the sine of 210 degrees. 210 is, again, in quadrant 3. So we're going to bring this up to the x-axis, and then we need to find what theta prime is. So our reference angle right here. So if this is 210 and this is 180, the difference between 210 and 180 is 30 degrees. If you have the sine of 30 degrees memorized as 1/2, then all you have to do is figure out the sines, but I'm going to help you derive it. So of course, opposite 30 is 1, opposite 60, radical 3, and the hypotenuse is 2. And so of course in quadrant 3, both x and y are negative. And if this is your angle of reference, then across from 30 degrees, opposite 30 degrees is the negative 1, adjacent is the negative rad 3, and the hypotenuse is 2. So for sine, we have some old hippie. So old is opposite, that's negative 1 over the hypotenuse, which is 2. And so your sine at 7 pi over 6 is negative 1/2, which again makes sense because only tangent is positive in quadrant 3, so sine must be negative. Finally, the last one. This is the only one that we've done, which is at a north, south, east, west axis pole. So if you get an angle measure, and this of course is in radian degrees, if you get an angle measure that is at 0 or 360, 90 degrees, 180, or 270, those are your north, south, east, west axis poles, then you're going to look at the ordered pair, which involves either a 0 or a 1. So remember, at these axis points, this ordered pair over here, and of course this is, and there's no triangle to be made for these ones. So this is 0, and then this is 90, this is 180, and this is 270, and of course this is also 360. Then we have our radian measure, which would be, I'm going to go with green. Our radian measure over here, this is going to be 0 or 2 pi, right? Depending upon whether it's 0 or 260, or 360, I mean. 90, of course, is pi over 2, which is the one we're actually working with. And then 180 is pi. And then this is 3 pi over 2. So if you have any of those in pink here or green, you're going to look at the ordered pairs. So let's just review the ordered pairs on each of the access points. Because our radius always has a length of 1, here we're going to go to the right 1, up nothing. And here we're going to go no right, but up 1, no right or left. And then here we would go left 1, which is negative 1, up nothing. And then here, no right or left, but down 1. And so don't forget that in your ordered pairs, cosecant of theta, comma, sine of theta represents your x and your y, right? So your x value of each of these ordered pairs up here, your x value is the cosine and your y value is the sine. Well, we have the secant of pi over 2, and hopefully you know that that's the same as 90. So remember the secant, put this down here, the secant is exactly the same as 1 over, the secant is the reciprocal function to cosine. Cosine of pi over 2. All right, so we have 1 over, and then the cosine of pi over 2, because as we look here, this is cosine and this is sine, right? So our cosine is 0, so I'm going to put 0 in place of cosine of pi over 2, and since we cannot have 0 in the denominator, the answer to the secant of pi over 2 is undefined, which I'm going to abbreviate as UD for undefined. It does not exist at pi over 2. And that's it for today. You are to finish the rest of your worksheets, or actually you're going to do the entire worksheet because you just worked on the unit circle yesterday. So you're going to do the entire worksheet for 13-4. Remind to text me with questions.